jump into this and try and make it a bit short so we have time for good questions and answers and to talk about the future workshops. So I'm really just going to try to walk you through some of the findings and just sort of impressions from the workshop that was held in June. And many of you were there, but those who weren't, it really focused both on a set of hazards that we selected to look at and look at what data needs might support ASCE standards, manuals of practice, and other guidance, and also on trying to align the process of developing data, funding, and standard cycles, climate science, and all that, which was more on the process side. So just like this is a guide to reading the report. Now, first of all, we have an executive summary. If you just want the short read, executive summary, and then we also have key points in each sections in boxes. And quite honestly, if you read the executive summary and then went down to the key points, you would have a pretty good sense of what's in the report. Particularly because the executive summary was really done as short as possible. So there's a lot more detail in many of the key points, particularly for the technical hazards, which is about maybe 40% of the report volume. So just to go through it, I think, let me see, I'm trying to see because I can't fully see my screen here. But basically, section 1 is just the background, a lot on the different cycles of time, iterations of climate science, of federal funding, of the development of standards, and just how those might be difficult to mesh, and some effort might be needed for that. The next section is really about the priorities and needs it was a panel about the priorities and climate needs for 4 of the ASCE institutes. And this is really quite interesting and gives a very, a nice high-level view of some of the problems and climate change issues that are coming up in many of the different aspects of civil engineering. The third one actually, got into the industry proving ground from NOAA, but also a detailed panel on different programs and how they've approached co-development of data. We all looked to the earthquake hazards reduction program as a model of a continually funded, iterative, and really a successful place that we want to be in order to have the sort of coordinated funding. But quite honestly, there were lessons to be learned from the others as to how you operate perhaps in these more chaotic, heterogeneous environments as well, and how you take advantage of local partnerships, how you do build this core of expertise, even if you're not funding it continually through, for example, NIST and the wind program there. And finally, there was my talk at the summer at the lunch about the way to cut through a lot of uncertainty issues with global warming levels. And I'll back to that in a second. The hazard breakouts, we did do 6 of them. I will not go to them in detail here. I look to read them, but in each of those, there's a table that we extracted, a summary table of all the kinds of data needs relative to specific, mostly ASCE standards, manuals of practice, and other very sort of grouped use cases. We came up with tried to use the word use case to be generic about like standards, manuals of practice, guidance documents, just some civil engineering practice that's done a lot that needs certain types of data. And we ended up, or at least, I ended up kind of trying to group these together in conceptual units that actually need the same types of climate data. So I'm obviously approaching it from the climate data side here. We also had a set of process breakouts, and on the second day that I'll talk a little bit about. And the final section that Dan so ably brought together from all the notes and text that had been supplied was really a summary that is really brings together kind of a forward-looking way of what we need to do. So one last little thing, there's an appendix on climate-sensitive ASCE standards. This is almost becoming a tradition now. We updated it at the last one from a manual of practice that was done years before. And so we have a whole table of lists of those as well. So I kind of like to highlight that because it's one of the useful things. So some of the overarching needs here, I'm trying to figure out how to make that one smaller so I can actually see it. Did I just kill it? No. Can you see that? Can you still see it?
Yes.
See it?
Okay, good. Because I just hit something and I'm only operating from one screen and I usually talk from two. Um, so some overarching needs. Dan and I were talking about this and about what we really want to highlight. Really, the understanding and communicating uncertainty in ways that align with engineering risk management it cuts across everything. And one of the aspects is how to use and interpret like global warming levels as a way to sort of cut through a lot of the jargon and a lot of the complexity of climate science. Adapting to a 3 degree Celsius global world or a 2 degree Celsius global world or what as a sort of a target. And what is its relationship to risk and uncertainty? Because engineers really want to say, okay, that's great, but what does that represent in terms in terms of risk? Also, really determining the level of confidence and precision that engineers deem sufficient, because often engineers are more tolerant of uncertainty than people outside the engineering profession, maybe me before I engaged in this, are aware of. One was to assure continued engagement across the ongoing standards updates, like don't drop the ball on what we're doing, but also to capitalize on that work. ASCE 7 future conditions is, dealing with wind, dealing with heavy precipitation, um, dealing with coastal flooding. And uh, as we saw in the breakouts, uses in other standards, uses in other, even in other across institutes. So we identified many small opportunities that could be followed up there just to extend the use of existing or very similar products. To expand the understanding and needs requirements, we really did a lot at the workshop, to other institutes beyond the ASCE 7 future conditions, uh, to guidance documents that may not, and institutes that may not be as focused as much on standards, which often require a bit more complex information. How do we approach developing climate projections for manuals of practice or other types of engineering guidance, which require more complicated? Um, and the final message that Dan mentioned was just better establish the economics of mitigating future hazards. There's a report out, National Institute of Building Science report called Mitigation Saves that was mainly about present day hazards, but really to focus on the economics of mitigating future hazards. Now, why is this? There we are. So some of the process priorities, well, again, trying to, everybody looked to the earthquake hazards continually funded model, to work towards something that's iterative, repeated, continuously funded, that you don't have to put together bits and pieces of your programs to actually make it work, to improve climate data products and services. And, something like the industry proving ground is only a 2 year basis beyond 2 year cycle. And also to seek out increased flexibility where possible, because perfect alignment will not be possible. I just say not likely, but it's not possible. Cycles of standards updates are not going to be the same across the board as the cycles of the IPCC and assessments of climate that really drive a lot of the updates in climate science. So there will be need to see flexibility where we can. The process breakouts really talked about 4 near-term goals. One is interim data and products, not to wait for your roughly update cycle for many of the standards, to see that we could develop interim products and mechanisms. Many of the through other institutes could be faster things, other types of guideline documents, even manuals of practice that don't have to go through code updates and go through the whole code adoption process. But not to lose sight of the fact that the codes really do stronger incentive in many places to adopt these things, to adopt, climate ready practices. Education and outreach, things about like new products like the NOAA's Atlas 15 of precipitation frequency, use of the sea level rise projections, for example, non-stationary methodology, global warming levels, just how to really approach these things. We're trying to trying to develop products that simplify some of the previous complexity that people ran into that I've certainly found to be a barrier to adoption in the past. Need for implementation planning, not just strategic planning on how to co-produce information. And finally, the return on investment part. And here I mentioned that mitigation saves report, but really something specifically for the climate change component. I know there's information out there. Part of it's just gathering information in one place, but also specific work on more specific hazard-based work. And what I just heard is very clear that a lot of people have approached this in a very, practical way because you have to do it for these property assessments. So I suspect that there's a really rich terrain there that we could actually seek out. Options for deeper dives. Groundwater came up a lot, and we had the Geo Institute there, and the water soil properties, often driven by temperature and precipitation inland, and also by sea level rise, coastal sea level rise, came up as a big one. Climate modelers tend to shy away from that because groundwater tends to be very local in many respects. But I do suspect that we could actually get a meeting of the minds there. And so that's to really get, like, is groundwater going to go up or down? Often directionality is all that's needed. Provide data for easy ingestion into watershed scale, provides multivariate data sets for hydrologic modeling, water supply, regional flooding for surface energy flux in the Arctic, for cold management, consistent sets of data to support compound flooding, and beyond just single variables like wind hazard, you get to these hazards that require multiple and coordinated sets of atmospheric and climate and hydrologic variables. Some comments, overall comments on drivers of increasing climate data needs. One is the move from observational to model-based estimates necessitated by projections. If you're going to make a projection, you really want to have some sort of modeling component. That often means you have to redo the entire assessment, even of the historical period, to understand how the models performed. Great example of this is on the ice deposition on structures, which is really difficult to do from modeling, much more difficult than from observational estimates of freezing rain. So that they're tackling that, and it's really quite interesting, but also a bit daunting. One thing I hear is even more and more is the reliability-based standards require more climate information and more sophisticated treatment of the tails of probability distributions. There's increasingly sophisticated treatment loads, and also of compound flooding. One last reflection sort of on data delivery. I heard a lot about like one-stop shop, but as I just heard here, know who you were speaking to. There's a spectrum of audiences, and I'm not saying you have a totally fragmented landscape, but there's a spectrum from those who just need to look up some values to perform an engineering calculation, all the way to the developers of standards who may need a terabyte of model output. And to really think what this middle ground looks like and how you actually serve that of engineers who are doing their own analyses, or a manual practice which has to apply a process in a certain area rather than simply looking up values. That's really where some of the work is going to be done on trying to really figure out how to deliver the data effectively. But many of the examples in the workshop were really focused. They weren't like broad one-stop shops. They were, this is the seismic hazard map, this wind hazard map. And then those may be combined in something like the ASCE hazards tool. But still, they're very focused analyses. And going beyond that is going to take some thought, is my thought. The last thing is we really got directions for the task force from this. And really to continue the co-development of climate information, the discussions around that, and facilitate that. The cross engineering discipline dialogue has been really, really important. And, also the cross, federal agency dialogue, the third bullet there, just building on past efforts to forge new connections. And the fact that many climate scientists are now serving on these, future-looking standards committees is a great, more and more doing that now is a great thing in my view. I mentioned the thing about integrated and user-friendly environment, but I really do think we have to understand the market and the audience for this data. And finally, to develop a process um, to prioritize among this, given the information we got from the workshop. So here's how to engage. It should be published by this Friday. Um, there's monthly meetings. We will have a workshop on 25, the ASCE Inspire conference, which will be folded into the convention, if I understand, and the ASCE National Convention. These are how we do it in the task force. So with that, I think I will go back to you all.
All right. Thank you, Joe, so much. I appreciate it. If some of you were wondering why it took over 6 months for this report to come out, or this Joe's summary has components of it that you don't really remember, I just wanted to underscore, Joe basically went back and reviewed, I would probably say 80 or 90% of the recordings that we made during the summit to help him flesh out initial drafts. He also worked with the hazard leads that facilitated the hazard discussions. So Joe and Megan both, I don't want to leave Megan out, put a tremendous amount of work into this report. I think a NOAA reviewer referred to it as the tour de force. So I'm really proud of this report. When we make it available, I would suggest you review some parts of it, because I really want to think about, over the next couple years, how do we build on this? And so that's really what the thought I want to leave with you is, I think we're getting a handle on the technical needs. It's never going to be perfect because there's so many diverse engineering applications here. But I think what we're going to start doing is moving into a phase where we're trying to implement some of this. We're trying to complete, like, the future conditions chapter of ASCE 7, I think is going to be really pivotal. But how do we keep the momentum going? What does it really mean for NOAA to provide some of these projections and data sets? Are we going to really use warming levels? Is that the key to making this a little bit more manageable? So there's a lot in there. I've now reread it a couple times. I think it really needs to be kind of the foundation for how we plan the summer workshop, which is kind of my way of moving into that discussion. But before we do that, does anybody have any questions for Joe? All right, Joe. Well, I think the reason you're not getting questions is because you did such a great job of summary.
Well, they haven't seen the report. They haven't seen the report either. But I do encourage you to, I don't think we need to write another report like this. We did the one 2 years ago and this one, and between the two, we have a pretty good view, at least of the people of the institutions we've worked with, of where the opportunities are. And I really do think on these opportunities now that we need to do. And I don't look forward to, I'm not across this. I do think what we have in there is the seeds from which the rest of it will sprout. So yeah, keep it in mind, and just keep it as a reference more than just as a record of the conference of the workshop.
Go ahead, Jennifer.
Real quick, could you flip back to the slide before your personal reflection? There, right there. Yep, that's the one I wanted to see. And drivers of increased climate. Okay.
Yeah.
Compound flooding. That was the one I missed. Compound flooding. Okay.
Yeah. The one thing that we haven't talked a lot about is just, for example, in ASCE 7, there's a combined loads chapter. And they're moving from like this, this what was called the arbitrary point in time approach. A lot of them are doing the statistical copula treatments or actual simulations, and particularly when you do reliability-based calculations, we set a reliability target rather than just a hazard target. Then all of a sudden, as a climate person, I'm saying, well, whoa, wait, you're asking for a lot more data here. So just being aware that the engineering practice and the way engineers estimate these risks is, for me, is also shifting. It's not a fixed target. The hazard may be fixed, flood level, but how it's estimated you know, is becoming more sophisticated on the climate and on the engineering side, and that was just it's something to be aware of more than to worry about, I think. But you know, yeah.